We are going to hear Yogi Schulz about bridging the chasm, aligning data science and traditional information system. Mr. Schulz founded Corwell Consulting. The firm specializes in project management and the information technology related management consulting in upstream oil and gas industry. In recent years, Yogi was advised on using data analytics on business values. Mr. Schulz has 40 years of experience of information system experience, of which over 40 have been spent as a consultant. He holds a BCom from the University of Calgary, and he's a member of PMI, CIPS, and hold its ISP designation. Yogi has presented at many conferences and write monthly blogs in itworldcanada.com. Yogi served as a member of board of directors of PPDM Association. He has written monthly columns for Computing Canada and the Calgary Herald that address IT management issues. And so that is the awesome, the speaker we have it today. And we will be listening or we will be learning from a lot of his experience. So other than that, please make a comment in the chat box and ask questions in Q&A session. And then upvote the question you like to ask. We have some time at the end where Anja will ask some questions, the best questions from Mr. Yogi, and whatever the questions get high voted. We will finish 5 minutes to an hour to allow to get back to the floor area and maybe navigate to the other room and say hello to other people. We encourage you to live tweet during event using hashtag YYCDataCon, and our Twitter handle is YYCData Society. And for this moment, we are recording this event. It is available on remote platform after the event for 3 weeks, and it will be published for some of the events on YouTube and LinkedIn. And thank you. And we will be, Mr. Yogi will be joining us for this talk. And thank you, Mr. Yogi. You can go ahead now.
Okay, well, thank you for that introduction, Rita. I guess we're ready to start.
Right.
Okay, I'm going to share my screen now.
Okay.
Everybody can see that now? Rita? So, welcome to Bridging the Chasm, aligning data science and traditional information systems. So thank you to the YYC DataCon organizing committee for inviting me to speak today. This is inaugural conference, looks like a big hit with many engaging participants and fascinating presentations. As data science has grown in importance, it's countered the IS department with increasing frequency. Observing these encounters in some organizations is like watching two vastly different galaxies collide. There are many loud explosions, furious disagreements, blinding thunderbolt flashes, and a lot of misunderstanding. What's the source of these vastly different viewpoints? Well, nearly everything. Culture, education, work practices, organization expectations, attitudes, reward systems, and the reputation of the two communities couldn't be more different. In this presentation, I'll describe some examples of the profound differences between the sometimes inflexible IS department and the often swashbuckling data scientists. Narrowing these differences Building mutual understanding and replacing conflict with collaboration will deliver more value from data science for organizations. Who am I? I think Rita already handled that. I'm an IT consultant, worked in the oil and gas industry for many decades, including a lot of work in data analytics in the last few years. I think that's enough about me. So let's look at the outline for my presentation today. After some introduction comments, I want to talk a little more about application sustainability. I think differing attitudes about the importance of sustainability are at the heart of the chasm between data scientists and information systems, and we'll explore that today. And then I want to talk about most of our time here today discussing these 10 chasm topics that I think are important topics for every software development project. The way data scientists and information systems address these topics is hugely different. And then we'll wrap up with some conclusions. And I hope you'll find this interesting, and I believe that we can narrow or bridge the chasm between data scientists and the IS department, and thereby position our data science projects for greater success. So here are some learning objectives. I'd want us to recognize that the chasm between data scientists and information systems can be a project failure factor. In most organizations, data scientists need some level of cooperation from information systems. Where that cooperation can't be achieved, frustrations and tensions run high. This dysfunctional situation can lead to project failure. The second learning objective is to recognize that project characteristics will help you anticipate the likely chasm issues. Project size, data access requirements, number of data sources, planned technology, business urgency, number of stakeholders, all influence the chasm issues that a data science project will encounter. Third learning objectives, understand the sources of these chasm issues. The sources are a result of factors including prior software development project experience of the individuals involved, their education, and the roles that they've held in their career to this point in time. And the fourth learning objective is to learn the actions that can mitigate these chasm issues. We can narrow or even eliminate these chasm issues by introducing a little discipline and some level of formality. Overall, the higher level goal for my presentation is to determine how we can improve the practices of our data science projects and to determine how we can improve collaboration between data scientists and the information systems. So got to have a Dilbert, machine learning in the world of Dilbert. I need you to do an AI ML analysis on how big to design our planned natural gas processing plant. What conclusions do you want me to reach? Well, we'll do whatever the data says, which is, oh, I already told management the size of the gas plant will be 326 mmCF per day. So as data scientists and software developers, we need to patiently understand what we do to management. We need to prevent management from jumping ahead to conclusions and recommendations that the data does not support. In Dilbert land, they obviously always get it wrong. Okay, so let's start by talking about sustainability. I believe divergent views about the relevance and importance of application sustainability are the source of the gaping chasm between data scientists and the IS department. We determine how much sustainability we need right now, later in the project, or once an application has been deployed. Then we plan accordingly and narrow or eliminate most of the chasm issues. So what is the importance of application sustainability? Perhaps not surprisingly, the IS department and data scientists have hugely divergent views on this topic. The IS department assumes everybody wants these abilities. Together, these abilities define sustainability in their production quality applications. Together, these abilities deliver a superior, consistent, user experience for all applications. However, the assumption that everyone wants these abilities is not accurate. Many people don't even recognize that they want these abilities. Data scientists, for example, don't pay much attention to these data abilities. Many data scientists react with, who cares, when they're shown this list. So perhaps these abilities aren't as important to success as the IT department assumes, or even asserts. Even when end users and executives haven't expressed any interest in these abilities, the IS department almost always assumes or insists everyone really does want these abilities. The IS department knows full well that the moment that an application outage occurs, their phones will start ringing at the IS department with everyone wanting to know, demanding to know, why this problem hasn't already been fixed. However, many data science projects don't actually need to produce production quality applications. So the IS department is often overreacting or overreaching by promoting or even insisting on these abilities. So that's the chasm between the two organizations. So how much sustainability should you plan for? So no sustainability. What that means is data scientists often think that the amount of attention that needs to be devoted to sustainability is none. They often think that the key deliverable is an exciting list of insights. Therefore, after the insights have been explained, the associated code and the data can be thrown away. Therefore, sustainability features in the design is a waste of time and money. In my view, this logic only applies to the simple case where the project is about exploration of the data to test a hypothesis. In this simple case, there's no intent to reuse the software created for further exploration. I believe that the larger your audience or number of end users is, the more likely it is that you are building a production quality application, whether you recognize it or not, and should therefore incorporate more sustainability features. So for example, let's take the category of some sustainability. If the application is intended to support a single individual, you likely only include some features such as backup and maybe some error checking. Modest sustainability, if your application supports only a single work group, you likely include modest sustainability features like data integrity, checking, performance monitoring, and improvement. Considerable sustainability is required if you have a large audience. Features like high availability, easy restore to a point in time are important features. Another dimension that influences sustainability is application complexity. I've illustrated that with these two graphics. The one on the left illustrates low complexity. The one on the right with many charts illustrates high complexity. By complexity, I mean factors such as number of data sources, number of variables in the model, sophistication of the statistics in use. I believe that in most cases, data scientists are short-sighted on this sustainability topic. After data scientists complete the presentation and receive adulation of their work, management often asks a data scientist one or more of the following questions. Can you run the model again with the following tweaks? Can you enhance the model by adding the following additional data sources? Can you rerun the model on a regular basis as the underlying data changes? I think in all those cases, the data scientists typically answer with, yes, of course we can, and then fail to add the following caveats. The results you've seen today are based on a prototype, not a production quality application. We are pleased to continue our work since you've obviously demonstrated value, but we will need additional resources to move towards a sustainable production quality application. Not hearing these caveats leaves management with the assumption that the data science application is ready for routine production use tomorrow morning. And I think most of us know that that's not true. So, thinking about these project types, how much should I listen? How much should I pay attention to this presentation? If you're absolutely sure that your data science application needs no sustainability features, you're welcome to doze off and perhaps go outside the room and eat a cookie or go upstairs for breakfast. I believe this is a rare case. Every reasonably successful application, data science applications included, will grow in size of audience and complexity over time. If you believe that your data science application needs only some sustainability features, please listen to the balance of the presentation, but you're welcome to multitask. If you believe that you need a modest number of sustainability features, please pay attention and avoid distractions. If you come to recognize that your data science application needs a considerable number of sustainability features, please pay attention to the balance of the presentation and take notes. Okay, so that's what I want to say about sustainability. So what does Dilbert say about that? As we've learned repeatedly from reading Dilbert cartoons, the Dilbert gang is often on the wrong track and ends up at a totally dysfunctional place. So here's Wally thinking, I wonder how the boss wants us to handle sustainability. So I'll try. I think we should virtualize the AI model and move it to the cloud. Hey, that's a great idea. Wally thinks, sustainability is a piece of cake. Well, Wally's Bafflegab is not a good architectural choice for AI ML applications. Sustainability is valuable, but it's not a piece of cake. Sustainability costs effort and money and requires architectural thinking. Okay, moving on to the chasm topics. There are quite a few topics that underlie the gaping chasm between data scientists and information systems. You'll notice that how we choose to address every one of these topics can contribute to, on one hand, or undermine, on the other hand, our data science application and our development work. How we choose to address these chasm topics can contribute to success or failure. So here's the first chasm topic. The IS department, when it thinks about project kickoff, thinks about a project charter that describes the project charter. It's been thoroughly reviewed with the project sponsor and the key project stakeholders. The goal is to achieve a consensus among key stakeholders about why the project exists, its likely benefits, its estimated costs, and likely risks. The data scientists, on the other hand, start projects with a barely legible hypothesis that's scrawled on a whiteboard accompanied by the large PLO letters in a messy workroom. The goal is to enlist the creativity of the project team to prove or disprove the hypothesis. So how do you reconcile these vastly different approaches? I think data scientists need to document what they're thinking about a little more, and the IS department needs to exhibit a little more flexibility and accept a less comprehensive standard. So I want to talk about the recommendations that apply to each and every chasm for a moment. What we first need to do is quit talking past each other. We need to lower the temperature, listen to each other more, and appreciate the experience and contributions of the other party. Then we need to explicitly determine how important or necessary sustainability is to our project. Sustainability determination leads to a formality discussion. More formality in the production of project deliverable leads to more sustainability for the completed applications. More projects that fail due to insufficient formality than due to too much formality. Don't believe that informality is somehow faster or cheaper, and running code is never the only deliverable of your project. Examples of other deliverables include design, risk assessment, data profiling results, model and methods research. The next thing is to clarify the division of roles and responsibilities. Be clear on what the data scientists will work on and what the information systems department will contribute. A consensus on roles and responsibility leads to a positive collaboration and eliminates unhelpful conflict. Move to a shared understanding. The reality is that you should never believe that the project team members or the IS department hold a shared understanding of anything, especially at the beginning of a project. Examples of project characteristics where there's no shared understanding include things like approach to the project, scope, design, like considerations like algorithms and models, relevant data sources, risks, roles, and responsibilities. And over time, a successful project team achieves consensus on and a shared understanding. Okay, business requirements, our second chasm. IS department expects business analysts to develop a formal business requirements document that includes both lots of descriptive text and diagrams. The goal is to elaborate on the high-level requirement statements in the project charter and to confirm the detail with the project sponsor. Functional requirements, non-functional requirements, and sustainability, as represented by the abilities I listed earlier, receive lots of attention. Data scientists, on the other hand, collaborate informally to develop the functional requirements using an online collaboration environment, lots of whiteboard space, a myriad of emails, and lots of texts. The goal is to bring leading research and data science experience to bear on testing the hypothesis. Non-functional requirements and sustainability receive little attention because they're seen as unimportant distractions. Again, how do we reconcile this? Determine how formal the business requirement document you need. My personal bias is that the act of writing down your thoughts greatly improves your ideas and weeds out ideas that are unlikely to be workable. The reality is most of us have more bad ideas than we have good ideas. And the sooner that we can weed out the bad ideas, the better off we'll all be. Application design. Another chasm. The IS department wants project teams to elaborate the many business and data requirement statements into a comprehensive end user stories and then prioritize the stories for development. The goal is to fill in the inevitable gaps in the initial requirements stated in the project charter, and also to ensure that the most important functionality is developed first. Data scientists, on the other hand, add to the design of their model iteratively, which as each execution reveals problems and new opportunities to converge on the hypothesis. The goal is to remove the inevitable errors in thinking about the hypothesis, and also to apply the latest data science thinking to irrefutably proving or rejecting the hypothesis. So again, how do we reconcile this? One of the problems is that iterative work can lead to losing sight of the goal or working down a path that may be endless or pointless. Informality is fine so long as the project goal isn't a production quality application. Informality also makes explainability of the model output more difficult. Next chasm, the software development methodology. IS department applies its accepted and sometimes overly bureaucratic software development methodology to the project characteristics. The goal is to ensure quality and sustainability in the planned solution. The IS department recognizes software development as a professional discipline that produces quality and reduces risk. Data scientists, on the other hand, views development methodologies contemptuously as straitjackets that constrain creativity at best, or as crutches that help dullards produce useful work at worst. The goal is to avoid a framework of this kind of structure because it might constrain creativity. How do you reconcile this? Operating without the formality of a software development methodology is fine so long as you can convince yourself that the problem space of the project is simple enough and small enough that you can succeed without the thoroughness that a software development methodology offers. Okay, data requirements. The IS department expects project teams to include data structures and data quality in the design to ensure that the planned application contributes to enterprise data management and data integrity. The goal is to avoid rogue applications that don't fit into the application portfolio and create operational or data integrity problems. Data scientists, on the other hand, like to scour the organization, perhaps the planet, for data with the ferociousness that V'ger consumed stars and planets in Star Trek: The Motion Picture. Data scientists create new columns and tables as their usefulness arises from the detailed analysis of existing data with no thought to data modeling best practices or data management considerations. The goal is to avoid anything that sounds or feels like structure that might interfere with identifying golden nuggets of insights. So again, how do we reconcile this? Being more formal about data requirements becomes increasingly useful as the number of data sources goes up and as some more data sources contain column names that sound very similar but may not be and might mislead the data scientists. Software development. IS department develops application software with rigorous peer reviews and comprehensive testing. The goal is to develop software with as few defects as possible to achieve production quality application. IS department recognizes that viewing software development as a discipline adds to sustainability and reduces expensive rework. Data scientists, on the other hand, like to keep coding until they see something they like. The goal is to fail fast and often on the road to a viable and defensible solution. The risk that an appealing result that appears to be a defensible solution but is in fact the result of a software defect is seen as low. How do you reconcile this? As software complexity goes up, the frequency of software goes up exponentially. At some point, more formal software reviews and testing produces a net benefit to the project. Success criteria. How do you know your project is a success? The IS department views success as delivering functional, stable applications for routine, no drama use by the planned end user community. The goal includes meeting the sustainability list I showed earlier. If the project is reasonably on schedule and on budget, that's a bonus. Data scientists view success as discovering breakthrough actionable insights in the organization's data. Sustainability and other features such as error checking, disaster recovery, data integrity are not part of the success criteria. The goal is to minimize the elapsed time to actionable insight. Because most projects are quite short, adhering to the budget is not an issue. How do you reconcile these vastly different approaches? Determine how much stability you need in the software. What is the risk of a breakthrough actionable insight actually being the consequence of its software defect that is confusing the model and misleading the project team? Operational methodology. The IS department is proud of their ITIL procedures that achieve high availability. These procedures implement the operational methodology to achieve a high availability computing environment and the other sustainability components. The goal is to ensure that superior customer satisfaction levels are achieved for end users of these applications. The data scientists never think about operational methodology. The goal is to find hidden insights that can outsmart the competition and advance the company's business plan by leaping over tall buildings. Data scientists are only building code and running it for themselves, never others. Sustainability is not needed in this case. How do we reconcile this? Both of these diametrically opposed positions are defensible. Ask yourself, what is the expectation of the project sponsor? If you can't articulate that, then you're really not ready to start the project. But once you can, then you can plan the project based on the answer you receive. Deployment. IS department plans the deployment of new applications with careful attention to people change management issues and the cutover from the predecessor application. The goal is to minimize disruption during the deployment and transition. Data scientists don't expect to deploy their software to anyone else, so they don't think about deployment. Awareness of the idea that software should be designed to run again next week or next month without a lot of babysitting or further development is generally absent. Usually there's no goal to move the code and data into production. So again, the reconciliation, how do we do this? The criteria for moving from an informal system to a formal application that can be deployed for routine production use are considerable. Decide which category your project falls in of the four that I described earlier and plan accordingly. A project elapsed time. This is our 10th Chasm topic. The IS department tries to minimize the project elapsed time, but achieving scope and quality typically take precedence. The goal is always a robust, high availability, production quality application. The data scientists understand how critical first to market is and focus on the shortest possible project elapsed time. Considerations of software stability, ease of use, data quality, sustainability all take a back seat. Again, how do we reconcile this? Perhaps the best strategy is to build a prototype that supports first to market as the initial project goal. And if business success is achieved, then go back and build the production system that will support sustainability. So those are the 10 Chathams ideas. So how does the world of Dilbert deal with this? Ming, I'm moving your data science project to IS. You'll report to Mordak. Oh no, how can this happen to me? We can still date, but I feel obliged to hate your guts now. It works for me. Another Dilbert ridiculous dysfunctional outcome. Data scientists sometimes have ambiguous feelings about working with the IS department. I hope I've explained the sources of the differences in background, experience, and culture. I'm optimistic, however, that the two groups can collaborate better with the improved understanding I've tried to communicate. So what have we learned today? I've discussed how differences in the background and the experience lead data scientists and information systems people to very different assumptions and approaches to creating value with information technology. We've discussed sustainability and how formality is required to achieve that sustainability. I've described these 10 topics that are the underlying reasons for the gaping chasm between data scientists and information systems. I hope the divergent descriptions made the differences clearer and more understandable. I suggest you explicitly determine how important sustainability is to your project and then recognize that conclusion in your approach to how you want to deliver the project, your project plan, your project budget, and the team composition and the skills that you need. If you'd like to add another topic or two to this list or want to challenge one of these, I hope you'll put something in the chat and we can discuss that in a few minutes. So what are the conclusions? The first thing is that software developed and data gathered to achieve the initial insight is a prototype. It's not a production quality application. Emphasize this point in your stakeholder communication because it's important. Otherwise, stakeholders tend to think your prototype is a new application that can be placed into production tomorrow morning. The second thing is that an appealing insight, line 1, will result in a request to rerun the application with variations in the data. That creates a need to support repeatability. And the minute you want to support repeatability, that triggers the need for some or even significantly more sustainability of your data science application. That's the moment to start including sustainability features in your project plan and in your budget and among the skills of your project team. Okay, so what are the recommendations that I invite you to consider as you leave this conference here today? Here's how I think data scientists should approach the question of sustainability. Think carefully about your project audience. The larger your audience is, the more likely you are building a production quality application, whether you realize it or not initially. If you can't figure it out what your audience size is, pitch the initial project simply as an R&D project with no expectation of production quality application as a key deliverable. The second point recommendation is to plan for sustainability. When you're asking for repeatability, when you're asked for repeatability, plan a new project that includes effort and schedule to incorporate sustainability in your project plan and budget. When you plan, use the upper value of your estimate for the size of the future audience. Collaborate with the IS department. Applying the IS department experience can make the difference between success and failure. Thirdly, educate your stakeholders on the difference between a prototype and a production quality application. Prototype applications run with the project team monitoring execution, fixing software defects and data problems on the fly. Production quality applications run on a schedule with no one monitoring execution and an expectation of no software defects or data problems that can crash the application. Fourth, don't disparage the well-established principles of software engineering. Software development has evolved as a genuine professional discipline based on many painful experiences accumulated over many decades. Your data science project is not somehow exempt from the principles of software engineering. You can't deliver faster by claiming the principles of software engineering are slowing you down or don't apply. What strategies would you pursue to bridge the chasm between data science and the IS department. Consider providing some of your thoughts in the chat. So my suggestions are: foster positive collaboration, eliminate unhelpful conflict, set the bar appropriately on sustainability and formality, and accept that the requirements of a production quality application are legitimate. So we've reached the end of the presentation, and in Dilbert land, they say, don't ask any questions, but we've got a question. How can you help us bridge the gaping chasm between data scientists and information systems? And management says, do everything soon and perfectly and right now. Totally unrealistic. So this is me. If you want to get in touch, there's my email address and our website and my phone number, and you're welcome to call me and talk about some of these subjects. And there's 2 slides here that illustrate what I've written on this subject. This is about data scientists and sustainability, and this is what I've written for a management audience about AI and ML. So with that, I think we've reached the end of the presentation. And I think we have some time for some questions.
Yeah.
What do you think, Rita?
Yeah, it was awesome. Thank you, Mr. Schulz. It was awesome presentation. And we have some questions, actually. I would ask, Angela, would you like to ask some question, or I can go ahead? I think first I can. You know what? I have with my experience, like I'm a master's student, so I did some internship program last year. So last year, like last year was all kind of online with the COVID.
Okay.
Yeah. So there was like, because I am a software engineer and I did my internship in as a scientist. So so I was looking for requirements. So when I went through requirements, and as a data analyst, I just go right to the data for the client. I look at the data, and the data was like so dirty, cleaning, pre-processing. And then when I show the data, like I just did coding in Jupyter Notebook. In the Jupyter Notebook, it is like that. You write a code, it shows right away results. And then I felt it like, the client was hoping like, oh, it is already done. Like within maybe 5 days, came up with the, like, the data, we have it, and how you visualize the data. I said, this is just like I'm learning about your data. This is not a, like, already built, like a prototype is done, or you can put it in. Yeah, that was the feel I felt it.
Okay, so Rita, you're describing prototyping.
Right.
And you're describing exploration of the data.
Yeah.
And I'm all in favor of that.
Right.
But at some point, I invite you to step back.
Yeah.
And think about the bigger picture.
Mm-hmm.
What is your goal? What is your design? And how will the code support some of those higher level goals?
Mm-hmm.
Don't just keep your head down and go code all the time.
Right.
My pitch is step back.
Yeah.
After the initial exploration.
Mm-hmm. Okay, got it.
Is there another question you want to read out to us, Rita?
Yes. So, is it overwhelming apparent to you understand of IS and data science / tech? What is the best way to entrepreneurs to work with or learn from people with your experience? What is the best way for entrepreneurs?
Well, yeah. Okay, so there's 2 ways, two major ways. There's an enormous amount of material on this subject out there on the web. So I invite you to just do a basic Google search using the terms I've used here in the presentation and educate yourself. The other way to do this is to bring more experience and expertise to your project team, either by hiring somebody or by bringing a consultant onto the team to help with these topics. So that's kind of 3 ways to approach that.
Mm-hmm. All right. So we have a second question. What resources do you recommend for learning about technical project management to help avoid some of these chasms?
So there's a large amount of information about how to be an effective project manager out there, particularly in the PMI, the Project Management Institute community. And adopting some of those principles of project management can help your project be more successful, be more on time, be more on budget. What I find with technical people, data scientists, engineers, specialists, is that they focus on their discipline, and they do a very good job of that, and they neglect some of those other issues around the project, such as project management, stakeholder management, planning for deployment, local politics, that are often as important to the success of the project as some kind of creative, state-of-the-art data science solution.
Mm-hmm. All right, thank you. All right, so you brought up that we should not disparage the principle of software engineering. How can we be advocate and champion of these principles?
Correct. I definitely, I am, well, annoyed, upset when sometimes I hear people disparage the value of solid software engineering. You know, there are some interesting fiascos that have occurred due to insufficient attention to software engineering. You know, like the most recent Canadian example is the Phoenix payroll system, where Canadian government bureaucrats aren't being paid, and the government is paying hundreds of millions of dollars to consultants to fix this. It's all about poor requirements gathering and poor software engineering. So to find out more about software engineering, well, in this day and age where we Google everything, I think there's a number of places, Carnegie Mellon University is one, that has a whole focus on software engineering and what superior software engineering is all about. And there's a lot of discussion about Agile and Scrum and paired programming. All of these concepts have value to improve the quality of software engineering in all kinds of projects, data science projects included.
All right, thank you. Rayanne asked, we talk about the IS department and DS team. What are the thoughts on emerging role of data translator? The business was not represented in our chat today.
Okay, so the concept of a data translator, I think, yeah, you need to really pay attention to that, particularly in data science, where you have the problem of introducing bias in your model by over-representing certain variables. So for example, if age is important in your model of the population, if you have both age and birth date, for example, in your model, or if you have experience level of individuals in your model, you're representing the same concept 3 different ways. The other problem is that in multiple data sources, you're going to have very similar data and columns with very similar names, but they're not identical. or you think they're identical and they're really not, or they're different but you think they are the same. And a data translator can help a lot with that. And the comment that the business was not represented in our chat today, that's true. But that wasn't the scope of my presentation. The business tends to bring a whole different dimension to the problem, because what happens during the course of the project is the business, everybody gets smarter, but so does the business, and they'll shift what they're really asking for, and those represent major scope changes. And a good project manager has to be very careful about that. Yet business requirements are foundational to the success of the project.
Right.
That's a topic for another day. That would be fun to talk about that.
Exactly. So what is the best way to handle hybrid team or stakeholder with limited skill set?
Yeah. You got to figure out what's the skill set that you need to solve the problem. And often the skills of the team are not up to the mark.
Yeah.
Okay. So you have choices. You either bring in additional people or you educate the people that you have. Either way, that's going to cost you time and money. But if this gap is too big between what you need and in the way of skills to address the problem that you have and the capabilities of the team that you're working with, there's a high risk that the insights and the recommendations are not meaningful and may even be dangerous.
Right. That's nice. So we have another question. Would you say the dependency on industry standard data, model like PPDM, are becoming less prevalent with the rise in popularity of data lakes?
Okay.
Yeah.
So under the heading of transparency, I was a member of the board of directors of the PPDM Association for 20 years. So I think that PPDM has made a huge contribution to improving data management practices in the oil and gas industry. And in fact, every oil company on the face of the earth uses PPDM to varying degrees. And in many cases, they're not aware of it. So for example, if you're using AccuMap or GeoScout, you're using PPDM, and you may not be aware of it. And the community of people who are supporting PPDM and enhancing it and advancing it is growing. So I disagree with the statement that it's less prevalent. PPDM is still hugely prevalent and is expanding all over the planet. I agree with this statement that the popularity of data lakes is going up. I am not a fan of data lakes because data lakes just push the problem away. And you're forcing the end user to struggle to figure out what's in the data lake and how to understand the data structure, how to understand the meanings of the columns, and how to get a meaningful query running and a meaningful result set. So a data lake tends to improve data accessibility, so that's a good thing, but it doesn't improve data understanding, it doesn't improve data integrity, it doesn't improve data quality. It just pushes the problem out onto the desk of some poor end user who has inadequate understanding of the data and inadequate understanding of software development.
All right, so we have, would you be able to share the slides with us?
I'm assuming we are.
Okay.
There's a mechanism for doing that.
Yeah. And it's a who owned the data. I have no idea in which context is it, but is it the business data or?
Yeah, thank you for bringing that up. That's an ongoing tug of war. What I believe is that the IT department is responsible for managing the data. And sometimes they make themselves the gatekeeper of the data.
Right.
And I don't believe that's their role. So they're kind of have sharp elbows about that in some organizations. On the other hand, there's a need to protect sensitive data and sometimes private data, and the mechanisms for doing that are not very sophisticated. So the IT just says no to everybody, which is the wrong answer. But responsibility for issues like data quality, data comprehensiveness, that's very much the responsibility of the business. There's a term called data stewardship, which organizations should think about more to make sure that their data quality goes up, because many organizations find that their data quality is inadequate to support the needs of their data science projects, and that's a sad situation.
Yeah. Mr. Schulz, like I had experience with like I don't want to say the company name, but I was just doing that log analysis. So I collected the log data, and they told me after, like, because log data is like that, it's millions of entries get stored every minute or like that, right? So as a data scientist, I was cleaning up the data and storing back, and then they told me, okay, you are not allowed to touch this particular data because it has a sensitive information. So I said, okay, that has IP addresses of all the, like, when you have a connection, how many request made by this IP address or the particular IP address. So they said, okay, you're not allowed to touch this data, for the project. Other than that, you can do the analysis. So so it's like
Well,
it's a
okay,
business.
so when you say log data, do you mean IT log data or do you mean well log data?
The IT log data.
Yeah.
Yeah.
So whoever's saying that to you,
Yeah.
why do they have any right to say that to you?
Right.
I'd say, okay, why is that? That
Hmm.
that data is important to our project goal, so we have a choice. We
Yeah.
either adjust the project goal or you can't insist on what you're telling me.
Yeah.
So one way or the other.
Yes.
I'm often baffled that project managers accept these statements from others who have no right to make those statements.
Mm-hmm. Right.
So you've got to push back diplomatically,
Mm-hmm.
but push back
Right.
if it's important to your project. If it's not important to your project, don't make an issue of it.
Yeah. Right. All right. Thank you so much for your all the great questions, and then it is a lot of great learning. I am very privileged, like you. We have you on our um, on our community this conference. So it was really a pleasure. So
Okay,
thank you.
well, great to work with you on this, Rita.
Yeah, thank you so much. We will be go back head back to the floor, so then you can move around in the between the rooms, and the next session will be from 10:30 to 11:30. All right, thank you so much again, and have a great day.